Hello children, welcome to aimsindia's online classes. In today's video from physics subject, motion topic we are going to discuss. So let's learn about equations of motion children. So already we have learned different concepts in motion topic. So now we are going to learn about equations of motion for uniformly accelerated bodies. For uniformly accelerated bodies. So here the equations of motion, they are applicable if the body is moving with uniform acceleration. So as we have already discussed earlier in the topic, so motion means, what is motion? It is a state of change in position of an object based upon time. In how much time, how much position changed. Suppose if you consider this cycle race, the position of the cycle is changing continuously with respect to time. We can tell that the cycle is in motion, and based on the motion of cycle or motion of objects, earlier we were able to describe the terms like displacement, distance, velocity, acceleration, time, speed. So we have already we have discussed in detail about all these terms. Not only in this class, in your earlier class also, you might have learned about all these terms related to motion of an object. So zagging, driving a car, taking a walk, these are all everyday examples of motion. So the relation between these quantities like displacement, distance, velocity, acceleration, time, speed, the relation between these terms will be given by some equations. They are known as equations of motions. Equations of motion. So the relation between the terms like displacement, distance, velocity, acceleration, time, speed will be given by some equations, and they are called equations of motion. So when the body is in uniform acceleration, the relation between these quantities is mainly described with the help of three equations. They are known as they are known as equations of motion, or they are also known as laws of constant acceleration. Laws of constant acceleration, because they will be applicable only if the body is under constant acceleration. So the equations of motion, indirectly we can call them as laws of constant acceleration. So these equations, we have mainly three equations. They are used to derive the components like displacement, velocity, it may be initial velocity or final velocity, or time, acceleration. So if out of these quantities, if any quantity is unknown, then we can find it with the help of equations of motion. So but these can be applied only when the acceleration is constant, and only when the motion of the body is along a straight line. Because if the body, like this cycle, if it goes in curved path, acceleration changes. So acceleration will not be constant. So these equations of motion will be applicable for the bodies which are traveling in straight line. That is one condition. And which are having acceleration constant. That is second condition. So let's learn about them one by one. So we have first equation of motion. So consider a body having initial velocity u. Suppose any moving body, if its starting velocity, if it is at position A, suppose its starting velocity is u meter per second. Suppose it is subjected to a uniform acceleration A. We might have applied some force F. Because of that, some acceleration created in the body, its velocity increases, and the increase of velocity, suppose let it be A, because of force applied and because of increase of acceleration or increase of velocity in time t, it will cover some displacement and its velocity will increase and it will change its position over time t and it will go to a new position B after time t. There its velocity may be v meter per second. The velocity changed from u meter per second to v meter per second in a time period of t because of force F, which has created acceleration A in the body. Suppose this is the condition happened. So now what is acceleration? Change in velocity by time. Change in velocity by time. What is the change in velocity? Initially it was u at A, finally it was v when it went to position B. So change of velocity is v minus u. By how much time? In how much time it happened? T time. So acceleration equal to v minus u by t. This formula we can write by the definition of acceleration. So now, if t goes this side, if t goes towards LHS, it will multiply at equal to v minus u. Or if minus u goes towards LHS, u plus at, we can write it as v equal to u plus at, and this is known as first equation of motion. The relation v equal to at is known as first equation of motion. So the first equation of motion is v equal to u plus at. So it gives velocity acquired by a body in time t. By a body in time t. So its formula, we have derived it with the help of acceleration formula. With the help of acceleration formula. So we got v equal to u plus at. Suppose in the beginning time, suppose at t1 time it is at u, and at t2 time it will be at v. This v minus u is the change in velocity happened because of t2 minus t1 difference, which we have assumed it as t. So this v minus u by t, it happened because of force F and acceleration A created in the body. So v equal to u plus at is known as first equation of motion. It is used to find final velocity v acquired by a body having initial velocity u and uniform acceleration A. So final velocity acquired by a body in time t, which is having initial velocity u, acceleration A. For finding that, we will make use of first equation of motion. So we have 1, 2, 3, 4 quantities here in the first equation of motion. If 3 quantities are given, one unknown quantity we can find. If v, u, a are given, we can find t, or u, a, t are given, we can find v, or v, a, t are given, we can find u. Like that, out of 4 quantities, if 3 quantities are known, we can calculate the 4th quantity with the help of this formula. And displacement is not involved in this equation. Displacement is not given in this equation. Next. So we have second equation of motion. The second equation of motion is S equal to ut plus half at square. We have S, u, t, a, t repeated here. We have four quantities here, and final velocity v is missing in this equation. So in the absence of final velocity, to find the relation between these 4 quantities, we will make use of this second equation of motion. So it gives a distance traveled by a body. S means distance or displacement. Displacement traveled by a body in time t. Let the distance or displacement traveled by a body in time, let it be s. Let it be s. So the distance traveled by a moving body in time t can be found out by considering its average velocity. Let's see the derivation, children. Let's see the derivation of this. So, how to calculate average velocity? For deriving second equation of motion formula, we are taking the help of average velocity concept. What is the formula of average velocity? Final velocity plus initial velocity by 2. Final velocity is v, initial velocity is u, v plus u by 2. This is the formula for average velocity. But what is the normal formula for distance covered? Average velocity into time. If the distance covered is s, then s equal to what is the average velocity? V plus u by 2 into what is time? T. But from first equation of motion, we know that v equal to u plus at. So in the place of v, we can substitute this. U plus at plus u by 2 into t. So s equal to this formula. So u plus u, it will become 2u. So we can write separately u plus u, 2u by 2 plus at by 2 into t. This by 2 can be written separately. So 2 gets cancelled, s equal to u. If you multiply with this t, ut. Here we have at by 2 means half at. If you multiply with t, half at square. So s equal to ut plus half at square. We were able to derive this formula with the help of average velocity. So this is the second equation of motion, children. It is used to calculate the distance traveled by a body in time t. Next, children, third equation of motion. So the third equation of motion is v square equal to u square plus 2ac, or v square minus u square equal to 2as, v square equal to u square plus 2as, or v square minus u square equal to 2as. So here t is missing. In the absence of t, to find the relation between v, u, a, s, we will make use of this third equation of motion. So it gives velocity acquired by a body in traveling a distance s. In traveling a distance s. So the third equation of motion, we can obtain it by eliminating t. By eliminating t between the first two equations of motion. First equation of motion, we have v equal to u plus at. Second one, we have s equal to ut plus half at square. If we eliminate t from these two equations, then we could able to deduct this third equation of motion formula. So this is the second equation of motion. This is the first equation of motion. This first equation of motion can be rearranged as at equal to v minus u. U will come this side, at equal to v minus u, or t equal to v minus u by a. T equal to v minus u by a. Like that we can write. Like that we can write. And if we substitute s equal to u into, in the place of t, if we substitute v minus u by a plus half into a into v minus u by a whole square. If we substitute and simplify, then we will get this equation. That is one method. And we have another method. S equal to ut plus half at square, v equal to u plus at. We have two equations. Let's square on both sides. Let's take second equation. On squaring both sides, we will be having v square equal to u plus at whole square, or v square equal to u square plus 2uat plus a square t square, according to a plus b whole square formula. This u square will go this side. V square minus u square equal to, from these two we can take at, we can take 2 common, we can take a common. So what will remain? Ut plus half at square will remain, because here there is no 2, we can write it as 2 into 1 by 2. If 2 went common, here half will remain. From these two terms, if 2 is taken common, here u will remain, 2a is taken common, u will remain, t will remain. Ut, here there is no 2, so 1 by 2 will remain, because here we can keep 2 into 1 by 2. If 2 went common, then 1 by 2 will remain. So a went common, so 1a will remain, t square will remain. Ut plus half at square. And ut plus half at square is known as s. In the place of this, we can keep s. In this way also we can derive the third equation of motion formula. Next one. So we have three equations. V equal to u plus at, first equation. S equal to ut plus half at square, second equation. V square minus u square equal to 2as, third equation. So let's apply these three equations to a body freely falling under gravity. Suppose if a body is freely falling under gravity, if a body is freely falling under gravity, so then at the top point its velocity will be 0. Its initial velocity will be 0. Why? Because it is freely falling without any force. It is falling by itself. So we can take its initial velocity is 0. So freely falling body means we have to assume initial velocity is 0 and it is falling down. So acceleration due to gravity is acting down. So acceleration due to gravity will be equal to plus z, because it is falling down because of gravity. So the acceleration created in the body is due to gravity. So it will be taken as plus z, which is uniform, which is always equal to 9.8 meter per second square and does not changes up to certain height. So we can take it as constant acceleration. So suppose if t is given, we have formula v equal to u plus at. So v equal to, for freely falling body, u value is 0. So u is 0 and acceleration equal to plus z. So we can have v equal to zt, direct formula for freely falling body. v equal to zt, direct formula. Or we have another formula, s equal to ut plus half at square, where s is the displacement travel, but it is a freely falling body. So we can take it as sh, the distance traveled by the freely falling body. We can take it as h height. So h equal to, u value will become 0. So ut will become 0. Half a, in the place of a we can keep z, half gt square. H equal to half gt square. So the formulas are v equal to zt, one formula, h equal to half gt square, another formula. We can take these two formulas. Or in terms of h, when h is given, same, this formula only, we got h equal to half gt square, 2 will come this side, 2h, z will come down by z equal to 1 into t square, or t equal to, square will come this side, root of 2h by z. This formula also we can write for time. T equal to root of 2h by z. Or suppose if we take this formula, v square minus u square equal to 2as. V square, u square is 0, no need to keep. 2 into a value z, s value h. V square equal to 2gh. V equal to root of 2gh. We can have this formula. Or V equal to, from this formula, from first formula, V equal to Zt. We can write T equal to V by Z. T equal to V by Z. We can write this. Or this formula only. V equal to root 2gh only. V equal to root 2gh only. If square come this side, it will become V square equal to 2gh. Or V square by 2g will come down. 2g equal to h. V square by 2g equal to h. From three equations of motion only, for freely falling body, if you assume u equal to 0 and a equal to plus z, and if you make some changes, you can come to these conclusions. You can frame these 6 types of equations which can be used in the case of freely falling body. When time is given, we can make use of these 2 formulas. When height is given, we can make use of these 2 formulas. When velocity is given, we can make use of these 2 formulas. Final velocity, because initial velocity is always 0. Initial velocity is always 0. So about these graphs we can learn later, children. Next. Or it's a okay, we can learn later. Okay. During graphical representations of equations of motion, at that time we can learn. Next, children. When a body is projected vertically up, when a body is projected vertically up, so when a body is vertically projected up means while throwing we have to use some velocity, then only it will go up. It will go up to certain height until its final velocity will become 0. There it cannot go up. From there it starts falling down. So initial velocity will be u, but final velocity will be 0 for a vertically projected body. So initial position, let's take as origin. So and direction of motion, vertically up, going up, is taken as positive direction, but acceleration acts downwards. The ground tries to attract the body downwards. Acceleration is acting downwards, so acceleration to be taken as negative, because upward direction we have taken as positive, so downward direction will be negative. So acceleration is acting in downward direction, it will be negative. So a value will be minus z. A value will be minus z. Okay. And if you take all the formulas, v equal to u plus at. Here v is 0, u is u, a value minus z, t, u minus ut. Or gt will come this side, u equal to gt. This is the formula. Here we have got v equal to zt, but here we have got u equal to zt. There will be slight change. And we have s equal to ut plus half at square. We have s equal to ut plus half at square, but here One minute, children. No need to derive all formulas again. So only all formulas. There will be no change in the formulas. Here t equal to root of 2h by z. The formulas which are not involving u, initial velocity, in that there will be no change. H equal to of gt square. Okay, these two only. In these two equations there will be no change. These two equations there will be no change, and remaining four equations will be the same. Remaining four equations will be the same, but instead of v, what we will get? We will get u. We will get u here, u here, u here, u here. So all the equations are same, except here as v is 0, final velocity is 0. In the place of final velocity, we will be getting initial velocity. There will be no change compared to all the 6 equations. So same equations of motion only, children. We can make them apply for freely falling bodies and vertically projected bodies. So next, children. So in the case of motion under gravity, so the time taken to go up is called time of ascent, is equal to time taken to come down, time of descent, because all the equations are same. All the equations are same. While coming down, t equal to root of 2h by z. While going up, t equal to root of 2h by z for same height. So time of ascent, time of descent, both will be equal. Both can be represented with the same formula, t equal to root of 2h by z. And the speed with which the body is projected, means with what speed we are projecting the body. Again, after going up and while coming back again after touching the ground, with same speed it will touch the ground, but direction will be opposite. With plus u velocity it will go up, and with minus u velocity it will come down. There will be no change in the velocity. The velocity of projection, the velocity of hitting the ground will both be same. Next. So the body returns to the starting point with the same speed with which it was thrown. So these points we have to keep in mind, children. These points we have to keep in mind. Okay, children. Remaining problems or remaining points we can discuss in our next video. Okay, children. That's all for today. So that's all for today, children. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you. Have a good day.